Well, good morning to everybody. I'd like to thank Dr. Christian Smart, who didn't show up this year, allowing everybody to have a chance to get best paper. That was a good thing. I've got 3 mics on me. I kind of feel like I'm in the American Embassy in Moscow right now, so getting a little feedback here. So this rather long-winded title is talking about how we as estimators can increase our purview. We all of us focus on cost. I'm going to suggest to you, ladies and gentlemen, that there's some other elements that we could study. And we're going to talk about those today. So with that, we're going to talk about 2D demand. And then a concept some of you haven't seen before. We're going to talk about 3D value space. And then we're going to talk about how they come together to form a 4D system. And then we're going to talk about how markets pair to create 7D systems. Then we're going to skip ahead to n-dimensional systems. I'm not going to go up to infinity, but I will stop at 16 for you. And then we're going to talk about how the surveillance market evolved. And then we're going to show a little work about constraints that we can do here. And then we're going to sum it all up. So, Paul Samuelson once said that the only point in the market that can exist is the equilibrium of supply and demand, just one single point. Well, Paul Samuelson obviously never looked at business aircraft because you have, ladies and gentlemen, here 96 points that are doing just fine. And very interestingly, they form demand relationships that are based on a phenomenon we've discovered over and over and over again in markets, which we call self-aggregation. And the self-aggregation in this market accrues across 4 different barriers. So this upper demand frontier is the price-limited boundary for this particular market. The outer demand frontier represents a saturation point for the market. The lower demand frontier, you'll notice nobody's lower than a couple $1 million. This represents that nobody can manage to get a plane for anything less than that price. And then the inner demand frontier, very interestingly, all the guys in green, those are all airliners that have been converted to business aircraft. But there's several in there that are either entering the market or falling out. And Textron, for example, is losing all their planes that are in this group. And the only way you can stay in this group, if you're not making enough money, is to get subsidized. So there's Dassault planes that are in this group because Dassault's pumping money into they're getting money pumped in from the French government. And the Italian Piaggio, they're getting money pumped in too. So it's not a level playing field, but it is a playing field. And so we're going to ask ourselves, what can happen to us if we don't take the time to do this? Now, this is something, ladies and gentlemen, we could all do this way in advance of getting a cost estimate cranked out. You can pull this data and figure out what these barriers are. And they can show it to your people so that you get an idea what you're up against. So what does this mean then? Well, in 2014, Robert Bass, one of the Bass brothers out of Fort Worth, Texas, some of you people from Texas know this guy. Well, he decided he was going to build himself a business jet. And he came up with a development cost. And ladies and gentlemen, I'm here to tell you his development cost looked pretty reasonable. He was going to sell it development cost was going to be roughly $4 or $5 billion. And you do a little bit of arithmetic, take out a RAND study, and it looked pretty good. And then as we'll show you in a little bit, we did some value analysis. He wanted to sell these at $120 million a piece. Well, it turned out to be a good number too. But something happened along the line. They launched with only 20 orders. And we had this demand frontier that formed at that time in this market. And you can see that the demand frontier at that price suggests that he might get as many as 47 planes. But he wants 300 planes. So I started tracking this guy several years ago. And what I discovered was, 5 years later, They still just had 20 orders. Oops. So I wrote a little piece on LinkedIn in which I suggested that it was worth every penny, but there weren't enough pennies in the world for this thing to make its nut. And then a few months later, after I made this prediction, this place collapsed. It collapsed here. Now, lest you think this is only a commercial phenomenon, I'm here to tell you that this happens in government too. Because the government's got limits, even though they act like they don't. They have limits. Well, what do you mean, Doug? Well, let's take a look. In fighter, bomber, and attack aircraft, in 1996, there was a frontier formed by the planes that you see here. And 25 years later, it had only moved 2%. Well, what's the implication of that for programs that are going to try to be in this field here? Well, the B-2, some of you know, the B-2 ran afoul of this. They targeted 132 vehicles and they ended up getting 21 because they didn't understand that they had a price limit. Well, what else is going to happen in there? Well, I predict that the B-21, currently starting to go into a build, going to be finished, they say, in 2039. In 2018, I ran off and I told the Northrop Corporation in their offices that they weren't going to make it. In fact, I told them that they're going to get something closer to 53 of these things rather than the 100 that they want. Now, how do I know this? Well, this curve is so tightly correlated that the figure that they want is more than 6 standard deviations away from the curve. And so that won't happen. So they only can afford a few of these. Now, lest you think this is the only example I could pull out of military, there's others. Just recently, my alma mater, Lockheed Martin. Can you get a show of hands? Anybody from Lockheed Martin here? A couple people? Yeah, okay. Everybody ducks. They don't want to be targeted here. Lockheed Martin told the world, or the Congressional Budget Office told the world, that they wanted to get 100 AGM 183s with a starting price of $42 million. They wanted to get 100 of these, which, coming down the learning curve, would eventually be $14 million a piece. But if you go out and research the previous 20 years of buys for air-to-surface missiles, as I did, you discover that, and those are the buys there, those figures in white are the missiles that we have. You'll find that at $42 million, that's basically the intercept for this thing, or the constant at 1. And if you wanted to buy 100, you would end up being 108 standard deviations. 108 standard deviations past the curve. As George Bush would say, not going to happen. Not going to happen. So, virtually no chance of this happening. Well, Doug, you say that's interesting. What else can you make out of this? Well, you might ask yourself, what's holding these prices up? So we're back to the original chart here and say, we're just going to ask ourselves, what's holding up? Paul Samuelson would say that just the intersection of supply and demand. I'm here to tell you, that's not true. What's happening instead is that people really like, as it turns out in business jets, they really, really like speed, goes up to the cube power, and they really like cabin volume, big old space. And so, what we can do is we can not only plot this electronically, we can plot this physically. So this is a physical model of this. You remember we had the outer and upper demand frontiers. And this is what we're facing right here. We're facing these limits. And so if you wanted to help your bosses understand what's going on, you could have them actually literally get a feel for the market by touching something like this. Well, that's great, Doug. What am I going to do with that? Well, let's take a look. What we could do is we could recognize, we're going to highlight a few vehicles here. So the ones in yellow are highlighted on this plane here. What we could do is recognize that when we go off and do a study, people really like cabin volume in their planes. They really like that a lot. They want a big space, as we just saw. And they also want, as we saw, a lot of speed. Well, what that means then is that the market here has a preference for both of these items that are in this fashion right here. This is that. That is this is that. And you say to yourself, well, what's unique about this, Doug? Well, what's interesting, the observation that allows a lot of this stuff to happen is that when we're looking at the quantity-price relationship, we have no zero Z, we have no negative numbers. We have positive quantities and we have positive prices. And when we look at this value space, and there's going to be a cost surface below this, people, if you're making money. When we look at this value space, we also have there's no negative cabin volume. There's no negative speeds. You can have more cost than you have value, but we're going to be comparing one non-negative number to another non-negative number. And so what we can also observe is that when we looked at the demand plane, it has a vertical price axis. Well, this has a vertical price axis, meaning that 2D plus 3D equals 4D. So the four dimensions of this model are then cabin volume, speed, price, and quantity. Okay, well that's maybe moderately interesting to you. Maybe you think, well, if you've seen one 4D model, you've seen them all. Or not. So what this means then is that we're merging these two spaces together, this one plane and the space together. And so what happens here is we're discovering a different rule that applies in the market, which we call the law of value and demand. Not supply and demand, the law of value and demand, which states that the features of a product, features drive value. Value eventually will set the price, if it didn't originally. Price will limit quantity sold, and quantity sold is a feature. And people say to me, Doug, it's circular. Yes, we're going to see an example of that at the end. But this is how every market works. And so every point in the left-hand value space has a matching point on the 2D demand plane. These are ordered quads. They've existed since before anybody took the time to plot these things. Well, that's interesting, you might say. What can we do with that? So we could consider the market for turbofan engines, which looks a lot like that. It also looks a lot like this. This has been converted from the linear format you see there. This is log, 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 log. And so what you could say to yourself is, well, these are the engines that go into those jets, with the ones in yellow highlighted to match to their jets. And you could say, well, Doug, I'm starting to observe something here. You've got a vertical price axis here, and you've got one there too. What can we do with it? Well, I submit that we can observe that they have the same price axis, meaning that 4 plus 4 equals 7. This is a 7-dimensional model right here. So 7D models form between any two related 4D markets. 4 plus 4 equals 7. Well, what if we wanted more dimensions? You might ask yourself, have you ever noticed how Rolodexes and poster racks, such as the one shown here, have some interesting features to them? They have this upper limit, so that each card's got an upper limit, an outer limit, and a lower limit. And they all go around a common axis. And as we rotate the information about the axis, we don't lose it because it's coherent to the card. Well, you say to yourself, maybe that could be useful for us. Maybe we could get something out of that. Maybe we could do something that would actually give us more insight. Well, let's take a look. What can we do with that? We got some ideas. So consider these 3 general aviation planes. So these are their order quads for the planes as they show, as we see them here. We've got one plane that seats 4, another that seats 6, another that seats 8. They all have their individual demand points on the demand plane. They all have their value points in the value space. Well, we just noticed that something on a flat plane, like the demand plane, if we swing it about the axis, we don't lose any information. So what can we do with that? Well, it's exactly like a poster. We can rotate it. We just saw that we could rotate it. And so here we do that. We're rotating this demand plane flat against its respective value space. Now, with that then, what once took 180 degrees of arc is now down to 90 degrees of arc. So we can imagine we're taking these little 90-degree arc markets into say a 4-room house, as shown here. So market 1 could be those general aviation planes that we talked about with its 4 dimensions. And now, interestingly, when we add the second market, which in this case is ground beef, we have the same price axis, and then we're adding 2 value dimensions and a quantity dimension. Could be anything. We're also going to add markets 3 and 4. But what we notice here is a pattern emerging, which is to say that if we had one market, we have 2 value dimensions, 1 quantity dimension, and a currency dimension that will be common to everything for a total of 4. When we add to the second market, as we saw here, we add 2 more value dimensions, another demand dimension for a total of 7. We add a third, right, 2 more value dimensions and a quantity dimension. We end up getting a pattern like this. To plot in n markets, we need 3n plus 1 dimensions. Okay, well, what are you going to do with that? Well, let's look. You might say, well, we've got the center cylinder here. You see that little green cylinder in the middle there? Everybody, you see that? What can we use that for? Well, the CIA characterized GDP thusly about 10 years ago. They said there's a certain amount for agriculture, some more monies for industry, most of it for services, and they came up with this pie cut. So 78.3 trillion. And what we're going to do is we're going to divide that amount. We're going to make the radius equal to 1 eventually. Here, we're going to see this. And we're going to divide the total amount by GDP divided by pi. And then we're going to stick that into log space. Specifically log space. Actually, 16 degrees of log. To get more usage out of the space that we can allocate using these devices to compress and expand data. But in order to do that, this is part of the title of the paper, we're going to have to experience dimensional collapse. Now, these are mathematical dimensions, ladies and gentlemen. We're not going to have the roof fall in on us. We're not going to collapse height or collapse width here. We're collapsing market or mathematical dimensions. So what would that mean, Mr. Howarth? Well, let's start with a Cartesian coordinate system that most of us are familiar with from high school or junior high. And what we're going to do here is we've got a bunch of whole number ordered pairs here. And then we said, well, you know what? Let's put some radii coming out from the origin with whole numbers. And let's see how we can plot some ordered pairs. Well, now we have a very good idea where all this data is as we've placed it here. But if any of you ever noticed like a scissor lift with man lift or had an extendable mirror in one of your hotel rooms, you notice that they use these links to shift the position of the data. But the links, the link length, the link length, the link length never changes. So what does that mean? Well, if we lower the angle between the axes, we don't lose sight of where all the data is. We've got the data right there. We're not losing anything. Well, you say, maybe we could do that, play that a little bit more. So these are called polar parallel coordinates. And you say, well, do we have a limit to collapsing that? I go, you can collapse them anything you like, just like we could collapse the poster in any position we want to. So we can collapse them down to a really tight angle here. And then if need be, we can take it back to where it was. This would be dimensional expansion. So we got it down to 15 degrees, and now we're expanding it back up. Well, that's all very interesting. How are you going to handle more than one market at a time, sir? Well, let's examine that too. Compressing all the markets at the same time just extends the process. So what we're doing here now, ladies and gentlemen, is that green cylinder that we talked about back with the CIA and everything, we're imagining that green cylinder to be we're looking at a top-down view of the world's GDP. And that little pie section cut there is how we've collapsed two value spaces down to represent that market's portion of GDP. Now, you recall we already swept the demand plane down onto those value spaces. This is the angle between those two value parameters there. And so in this case here, we've got a market that hypothetically takes up 10 degrees of arc in the economy. Well, what would happen if we wanted to increase that? Well, we saw dimensional expansion before. We can expand it again. Now, some of you are already getting ahead of me here. I'm sure you're thinking that, well, geez, we could add extra markets, which we're doing right here. We're adding extra markets. We're showing what they are. And we've added a second. And we add a third. And of course, the extension of this is that there's no limit at all to how many we can do here. There's no upper limit. So what can we do with that? Well, I'm going to show you the model here of 16D, and then we'll explain it in detail a little bit later here. So what does a 5-market, 16-dimensional system look like? Well, it looks a little bit like this. These are real data points collected a few years ago. So dimension 1 is the currency axis, up and down. And then the aircraft market uses dimensions 2 through 4, package delivery 5 through 7, ground beef, and then internal combustion cars, etc. And so what we could do now then is you say, well, that's interesting. How do we account for all these dimensions? Well, you use dimensional accounting here. So we want to build up how this thing was built. And so what we do here then is we talk about the currency dimension is common to all, and then each band here represents each market. So civil aircraft, package delivery, United States meat, and so on. And we're adding, every time we're adding 2 value dimensions and a demand dimension. And by golly, as I said before, 3n plus 1, so n being the number of markets, 3 times 5 plus 1 equals 16. And so the key to reading each depiction of this market is thusly here. So what we've done is we've created floor-to-ceiling planes that intersect the industry, or that show the limits of the industry, services, and agriculture. We have this center cylinder that's got a radius of 1 so that we can push all the GDP into that. By rule, what we don't do is don't show each one of the individual pie pieces all the way up and down because we understand that. But vertically, we're going up by factors of 10. And horizontally, we're going out by factors of 10 too. And what we're also saying is that the upper boundary of each card, so for example, the card there for aircraft, the upper boundaries are about 300 million this time for the Airbus A380. The lower boundary might be something like a Piper Cub, down around 100,000. The outer extent of the card for demand represents how much was sold in a year. And then the outer limit of both, in this case, the speed and the seats, shows the maximum extent of that. So again, the Airbus A380 had about 600 seats and went about 600 miles an hour. So they're almost identical right here. And it turns out, again, the angle between these two tells us how much is in the market, about 2.2%. So, think, GDP, what can we do with GDP? Now, this is going to seem a bit of a break here, but I assure you it's only to get to our final answer, which we're going to go to in a little bit here. But a few months ago, after I wrote the book, unfortunately, so I couldn't stick this into the book, I found myself at the end of a trail run and parked my car up on some asphalt. And I'm breathing real heavily, and I looked down and just a single solitary reddish black, which I discovered later, reddish black rock ant, that's the colloquial name for this guy. I saw this little red black ant, moving about. And I thought, well, if Richard Feynman, the Nobel Prize winning physicist, can study ants, so can I. So I decided to give myself a couple minutes to study this little guy. And this little guy, he's starting to go in a clockwise fashion. He's going clockwise, 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 clockwise. And from the starting point that I saw him at, he's going clockwise, 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 clockwise. And eventually gets to 360 degrees of arc. And he's out just a little bit further than where he started. And then he goes around and he makes another loop. 720, he went 720, and he's out further still. And I continue to watch him. You know, we're on asphalt, and he's got these little fits and starts, and he's going around tracing another spiral leg here. And I realized that when he's stopping, he's on the high point for him. He's doing Bear Grylls thing. He says, when you're lost, go to high ground. Well, this guy's getting up on the higher ground, the highest piece of the pebble, to go around and look. And then it hit me. That little guy is doing surveillance. So I rush back to my house. I type in ant surveillance into a search bar, and I discover that, by golly, ants do recon. These ants do recon. And they have things they look for. In fact, when they're looking for a place to live, they study the same kind of features you and I do. They want a certain amount of floor area. They want the headroom to be just right. It can't be too high, it can't be too low. And they want to be away from the neighbors. So it occurred to me that in this big ant colony, this single little solitary ant that I saw, well, he's doing his contribution, his portion of what we could call ant GDP. His contribution of ant GDP is surveillance. Meaning that part of the collective GDP for ants is surveillance. So these ants have appeared way over 100 million years ago. And my hypothesis is that we're smarter than ants, therefore we've been doing surveillance since we first appeared on Earth. Now, surveillance has got a very interesting history, as you might imagine. So we're going to have a little bit of history here and then drive this into some analytics that we might want to do. So, watchtowers back in the 1500s were a way to gain early warning. If you were to float down the Danube and see a castle, pop into the castle and then look around, you're going to see watchtowers that will be the same construction as that castle because they wanted early warning. So here's an example, one that's a little bit east of Vienna. So in this particular town, they had very hilly terrain around it, and so they needed a lot of them. And this is another theme here, ladies and gentlemen, that since we're at a cost symposium, well, the locals having to pay the taxes for that didn't like the cost. So hundreds of years later, the French made the first use of surveillance balloons. And then in the Civil War, both sides made use of Civil War balloons. What they did, interestingly, is they take iron filings and they pour sulfuric acid over the iron filings, and it would release hydrogen gas, and that's how they filled this balloon up. Well, the balloons are great, pretty dangerous. You don't want to fall out of one of those things, and you could get shot at. So pilots had a little bit of a danger factor in this. It wasn't the safest way to go. What are you going to do? Well, we're humans, we innovate. Well, so World War I saw more advances. So this Caudron G3 was an improvement. This is a single seat. Well, actually, it's got two seats. There's a seat in front of this guy. This is used for training and reconnaissance. So here's a pilot that in a plane for which the Allies built nearly 3,000 of these guys. And it was flying faster and higher than the airships of the day. Pretty good. Pretty good. Now, I want to draw your attention, ladies and gentlemen, to the aft. There's the pilot. This is this little piece here. That's the aft fuselage. See the piece after the pilot there? His aft fuselage is intact. That's airworthy plane. He could go out and fly that, supposing everything else works. You see this pilot here flying the same plane? You see that he has lost his aft fuselage. You can see there a little cracking going on here. You see that this piece is no longer attached to that plane. There is damage on this plane. And you might ask yourself, because you don't know anything about me, how the heck did you get two pictures of this plane showing that phenomenon? Well, it turns out, ladies and gentlemen, that this gentleman on the right-hand plane was my grandfather. And he had his tail shot off by friendly fire. And by my calculation, if you'd been there 1/100th of a second or less earlier, I wouldn't be talking to you right now. So this is an occasionally dangerous occupation, flying reconnaissance during the middle of an artillery battle in World War I. So, government response. Let's go higher and faster. So after World War II, we had improvements. We had the U-2. Now this eventually was shot down, right? Of course, Lockheed still they made the U-2 for a while. It's still being flown. And then my alma mater, Kelly Johnson, came up with this fabulous plane, the SR-71, and it did great and wonderful things. But here we are at a cost symposium. That thing was too costly to operate. So what's the partially evolved response to surveillance? Now, some of you are in the surveillance market. What do we do with surveillance nowadays? Well, there's been some improvements. Let's take the pilots out. See what we can do then. Now, what does that mean? Well, we can assemble all the satellites that I could find. Now, there are probably maybe a couple of classified ones I couldn't find, but we got all the spy satellites for which we could get data, and all the military satellites, and all the unmanned air vehicles that can perform ISR. And by golly, wouldn't you know it, that though they have they have different forms, the UAVs, spy satellites and military satellites, they share an outer demand frontier, this one in yellow. Now, importantly here, you see the exponent of that is minus 0.133. That means that there's more money towards the top of the market for the really expensive satellites than there is at the bottom. And also, crucially, there is an inner demand frontier here too. So if your company is smart enough to get past building one unit, the government says, we're going to get you to get more units. Well, you've got a guaranteed minimum here by the government, ladies and gentlemen. And wouldn't that be nice for your employers to know that you've got a guaranteed minimum that you could show them because you did this kind of work? That would be very useful information to somebody. Well, the question might be then, Doug, that's why I call myself Doug, what's holding these prices up? Well, very usefully again, ladies and gentlemen, turns out that we can plot that too and solve for that. So it works out that these UAVs and satellites, not only in addition to having the same demand proposition, they have the same value proposition, the equation for which we'll see in the next slide. But buyers willingly pay more for payload, speed, altitude, and they pay less. This is getting back to where I said quantity is a feature. They pay less for each succeeding unit. So on the left, the black dots in each data set are the same. All those dots are the same. On the left, we're looking at a Mercury Edelin spy satellite. They built one. It's carrying close to 10,000 pounds of payload. It's in geostationary orbit, so it's going that speed. And it's worth, we paid for nearly $2 billion for it. But using the same equation, the orbiter UAV with 2 kilos payload, 3-mile high altitude, well, we've bought nearly 1,700 of those guys because of that demand phenomena. And it's only worth $50,000. Well, it's a cost group. I submit that successful programs need to balance cost, value, and demand. And so what you can do once you get all this data is you can assemble it all together into an interactive estimator. This one's going to be built in Excel to bound the problem. So again, the equation, you see this below the mid-grade chart, this equation explains the value of the satellites. And so what I've done here is I've got this equation and I've put those independent variables up in the left-hand corner in there. So this particular satellite's in LEO, but it's going a little bit less than 17,000 miles an hour, or 17,500 escape velocity. So this one's going to eventually decay. I put in some payload for it. And when I do all that, well, it turns out that this thing spits out a price. Now, the reason I've shown in the center chart the inner and outer demand frontier is to point out to you that once you set the parameters, and this is not well known to your bosses, once you set the parameters, figured out the price, you've limited demand. Now, I didn't do the whole number rounding here, but you can get maybe between 3 and 28 vehicles. Now, you see I've set that there's a little dot just to the left of the 290 there on the right. I've set my desired quantity to 20. And right now this shows, if everything else were to hold, you can go ahead and do that. And then on the right side, what we've done is that this quantity term here, quantity to the minus 0.28, this quantity term here is part of the feature of this market. Prices go down according to that exponent as you build more and more. And so what that means then, ladies and gentlemen, is that there's a product demand curve that forms. That is this blue line right here. Now this blue line has that slope, and it's much flatter. Remember, we had the other ones that were much less than -1. That slope means that this curve will always intersect the demand frontier. This is telling you what the frontier is. If you're designing something, you don't want the product demand curve to intersect your frontier before you get to your desired quantity. And also, what you could notice is that if your learning curve were greater than that slope, which is 82.4%, it's going to intersect product demand. Now, in this particular case, the way I've drawn it, that little dot right there is wedged in between product demand. The learning curve is right below it, meaning that it costs less than the government will buy it for, meaning that this is a conceivably viable program. Well, every time something enters the market, this thing's already out of date. I did it years ago. Every time something adds to the market changes. So you need to, what you tell your bosses is that I did a study 3 years ago where now we're in update umpty squat. I need to update my database so that I can do this again, so that we get more insight, because everything's changing. So, what have we learned today? Well, all markets work according to the law of value and demand. Basically, the features of the products determine the value. Value will set the price or drive it. Price limits quantity sold. Quantity sold is a feature. We can combine any number of markets into a single view. Each slice is their hunk of GDP. It's just like a slice in a piece of pie. And reconnaissance, like the markets, has been evolving over time. And so successful programs need to balance this all at the same time. So with that, I'll take any questions you might have. Thank you. Yes.
It appears that getting to the questions is a little bit more problematic than one might think. I do have one question. What if there are fewer or more than two value dimensions? You've provided many examples, but it doesn't seem like that's a law of physics.
Yeah, if there's fewer, the one thing I'll tell people is if you're looking at a commodity, a single feature commodity like gold, this doesn't give you, there's not enough intel in the market to separate pure gold, iron ore, platinum, things like that. So it doesn't work for single feature products, but if you get more than two independent variables, what happens is this hyperplane, you're going to get, hyperplanes are going to shift based on these other independent variables. And you'll be able to work with that.
There's a lot of eVTOL, electric, air taxis. It's kind of related to the aircraft industry. Could you just maybe point out where, with your laser pointer, where that might occur? Where will we see the eVTOL market in there?
Well, the eVTOLs are selling for between a few 100,000 and a few million. So if you were to point where they're going to be, they're going to start out with quantities of one. They're going to start in this lower corner. I'm glad you brought that one up, Steve, because the reason eVTOLs are emerging is that they've dampened the noise. And so we did a helicopter study that discovered the value of a helicopter, much like we saw with the airplane, is a factor of how much you can lift, useful load, how fast you can go. But then a third and fourth order effect is how many rotor blades do you have? Rotor blades, you say, what's that? Well, if you have just two rotor blades like a Huey, you're going to make more noise than if you have six rotor blades like a MD 600. And so we used rotor blades as a proxy for noise, Steve. And so that's one thing that you can use here. Ideally, if we were to go to a deeper study, we'd actually take the dB values of that. But it's going to form, as the markets enter, you're going to have the first unit's going to be down either just below this axis or just above it. Archer is trying to be the first one out the door with that. So
do you, just speculation, do you see that the air taxis like to and from your house to the airport, do you think that will be common for the general public, or is it the upper, for the rich and things?
Well, I think it's going to be just like the cell phones. When the cell phone first came out, only rich people could afford the brick-sized cell phone that we had. Wall Street, you see Michael Douglas going around with something that looked like a brick. But then, as people make more and more, Steve, to your question, then it's going to start to evolve, and the prices will fall. So it's going to start with the high-end market, to your point, and it's going to gradually inch its way down to the lower extents of the market.
So my question is, what sort of relationships can you determine from flattening those GDP pie charts on top of each other?
Well, you can determine where the market lies for your product. And when you start to flatten them, you're figuring out a bunch of things. One is how much money is in that market, and what's the minimum to enter the market? What's the minimum amount anybody's managed to penetrate the market with a viable product? So when I was looking at aircraft, it was right around to get into the general aviation planes, you need a few tens of thousands of dollars of value to get to that price. So it's telling you what the minimum is. And then Airbus, by the way, Airbus with their A380 didn't do this analysis. They thought they could go to 380. Well, at 380 million for the A380. And it turns out that prior to the Airbus being built, there were 822 Boeing 747s built in the 20 years before that, 822. And Airbus thought they would build 1,250 A380s at about 1.5 times the price. Well, so they wanted to have more vehicles for more price. That model right there would have showed them that it's probably not viable, and maybe they wouldn't have done that. So that's what it gets you.
Thank you, Doug.
Thank you.